Hello and welcome. Thank you for tuning in to this episode of the Fishbeck Learning Exchange. I'm Chris Freeland, and today we've got the perfect episode as we head into Engineering Week next week. The theme for Engineering Week this year is Design for the Future, and to help us explore what that means, we're bringing you something of a TED Talk, but with a twist. That's right. Joining me today is Ted Perron, a senior mechanical engineer and the market sector director for direct engineering here at Fishbeck. You may have guessed that engineering runs in his family, but what really fuels his passion for the field is the problem solving, the creativity, and the thrill of taking on complex challenges. So we're going to unpack that a little bit. Why mechanical engineering is such a dynamic discipline, the high-tech projects that he's worked on, and why the best engineers aren't just fixers, they're thinkers who ask why before they ask how. And if you know somebody curious about a future in engineering, Ted's got some great insights, maybe even the advice that he'd give his younger self. So, get ready for a conversation that's equal parts innovation and inspiration. Let's get into it. Ted, thank you for joining us. Welcome to the studio.
Yeah, thank you for having me.
Yeah, you bet.
I've never done a TED Talk before.
No? What, first one?
Maybe I've done infinite number of, I don't know,
every
thousands
time you
of them.
speak,
Every time
it's a TED Talk.
That's a TED Talk.
And it's also a dad joke that is just waiting to happen for anyone named Ted.
That's a good point. Yeah. I haven't used that yet.
You're ready. Okay, so let's start with just some basics about you. What inspired you to become an engineer? And yeah, let's start with that. What inspired you to be an engineer?
Yeah, that's a good question. I think, if we talk mechanical engineer versus engineer, I grew up.
Let's get right into it.
Well, I mean, there's obvious reasons, right? Nobody seeks out to be a structural engineer, for example, right? Mm-mm. So let's just start with that.
Shots fired.
But yeah, engineering for me, I grew up in a family of debaters, let's say.
Okay.
I mean, our conversations at the dinner table, you should have seen them. It was lively, right? And I think, looking back on that, it was my dad, he's very much a critical thinker. And so wrapped up in those, it's just, trying to understand things. And we would debate and talk about those. And, you alluded to it a minute ago about understanding why things are the way they are. So I didn't actually set out to be an engineer. You're in high school, young, math and science comes pretty easy. And so you're thinking, okay, well, what do I want to do after that? And I would say, yeah, my dad was instrumental in guidance and direction. My dad and Drew Brees, by the way.
Drew Brees?
Drew Brees, yeah.
Was he an engineer?
No.
But he went to Purdue.
Yeah.
Well, I know that.
Yeah.
Okay.
2001, right? Rose Bowl. So I was in high school.
Okay.
And I went to the Purdue, Michigan, Purdue, Ohio State football games. And these are the greatest football games ever in Purdue's history.
Okay.
Drew Brees is quarterback, right?
Right.
And it's why wouldn't I go here and I'll do engineering while I'm at it, right?
Yeah.
So yeah, I think, it was good. My dad set me out in that direction, right? He said, hey, if you don't know what you want to do, I didn't know what I wanted to do. I job shadowed. Did you know Todd Stelma?
No.
He was a structural engineer here at Fishbeck, I think back the old office.
Okay.
When I was in high school, I job shadowed him. I was probably maybe as a junior in high school.
Okay.
And I came away from that thinking I have no idea what engineers do. I mean, I job shadow him, right? And I'm like, I think they stand around and drink coffee, right?
Right.
What do you actually do? So I still didn't really know, but I just had good direction, if you don't know, and this came from my dad, right? And I had brothers that were engineers. I have some older brothers. I have a twin brother as well. And we actually all did engineering, but he steered me in that direction. I think seeing maybe some natural God-given abilities in certain areas and saying, it's a good route. So, you get into that, and that's what I did, go to Purdue. And, you learn pretty quickly, okay, this stuff came easy in high school, and you're sitting there in class, taking these math classes, and you're like, what am I doing?
Yeah.
I have no idea what's going on here, right?
A little bit over the head.
A little bit over the head,
on.
right? It's okay, is this really what I want to do?
Purdue engineering has a bit of a reputation. I've seen a YouTube video out there about an engineering rap. that they put together.
Yeah.
Okay. I mean, you sent it to me. It's full disclosure. You sent it to me.
Well, yeah, everybody should watch that. It's good, right? I mean,
maybe we'll put it in the show notes. Dan, we'll get onto that.
You should.
We'll do that. Maybe.
It kind of captures,
I don't know if it's okay.
everything that you think about engineers. I don't know. It probably reinforces it, right? So maybe it's not so good, but yeah. So just started out on that path. I mentioned I have brothers that are engineers. They do all different things. So one's a civil engineer. The other two are mechanical.
Okay.
And when I graduated from college, I needed to find work, and I needed to be here local. I was getting married right out of school. My wife had one more year at Western Michigan.
Okay.
And so I just called up. I'd worked for a mechanical contractor when I was in college over the summers. I called him up and said, hey, do you know any engineers hiring? And that got me my first job. And I started doing it. It's really interesting because I don't think many mechanical engineers set out to go into the AE industry. I think you think of, mechanical engineers and mechanical parts like machines. And
right.
My one brother, he worked for L3 and then Lockheed Martin designing Black Hawk helicopters and parts and components for that. And it just sounds cool. And like when you're an engineer, that's what you think, right? That's what I want to do, right? I want to, automotive is huge and all that, right? But this is an industry that's not really on your radar. But the funny thing is, as I got into it, and I had a very direct comparison. This is twin brother, both went to Purdue, doing mechanical engineering, but very different things. He's no longer doing that, not even anything close to it, because he's like, it's not that great. It's just not, it sounds good.
Blackhawks.
Yeah. Who doesn't like that, right? That sounds awesome, right? He's like, it actually isn't that great. I mean, it's good to some degree, but yeah, I think what I found is, as I got into this, the variety of the types of things that we do and how many different types of projects that we're on. And then I think the different range of skill set that you get to use as an engineer in our industry it's a lot broader than designing, parts for Black Hawk helicopters.
Right.
So I think that's what's attracted me.
You said before, not today, but when we were talking about this before, you said mechanical engineers can do anything. They do everything.
Yeah.
So that versatility is part of the draw.
Yeah, sure. If I go back to when I was younger, I thought the same thing. I actually going into Purdue and I'm trying to figure out what engineering do I want to do. And I thought maybe aeronautical or aerospace, right? Again, it sounds cool, right? But then someone told me, and I think they're right, you should really think about mechanical engineering because a lot of what they're doing, it kind of falls under that mechanical umbrella. And so it opens doors, right? You may want to go specifically design Black Hawk helicopters or something in automotive or whatever it is, right? And those doors are open. But I've just found that this industry that we're in, I never would have thought. I've been doing this stuff for just about 20 years in June. And I wouldn't have thought that I liked it like I do. But it's because there's so much variety in it. And again, the skills that you're able to use, and it's not just, sitting behind a desk and designing. And
I wonder, like, you could probably have a YouTube channel, maybe, depending on how into that stuff you are. But like, if you see some of the YouTube channels out there that are engineering focused, I haven't seen them all, okay, obviously, but a lot of mechanical engineers have one, and they have really cool, like, how to like defend your bird feeder from squirrels, stuff like that.
Yeah.
And they're hilarious. And they're good at the YouTube thing too, but the mechanical engineering aspect to it is what is really the meat of it.
Yeah,
and
for sure.
So that might draw some people into it too now, because now they have this as another channel to like show what you can do with that sort of degree. Not just be a YouTube star, by the way.
Yeah.
But
well, that'll be the next episode, Learning Exchange, right? We'll
put it, Dan, put that on the schedule for sure.
How to protect your bird feeder.
Maybe that could be like an engineering week challenge. Maybe not this year. That's like next week.
Yeah.
But,
well, that's a good point, right? You talk about engineering challenges and that type of thing.
Yeah.
The types of mechanical projects you do, and even going back to when you're in school and you're designing different things. And my senior design class, we were designing an autonomous vehicle, right, to participate in the DARPA military challenge, right?
Okay.
So you're doing stuff that's really cool, right? But you also design these things. I got to say, David Layman-Kuza in our department he's a great example of how a mechanical engineer thinks about things. And he's really creative, right? And so back when we did even you remember the miniature golf that we used to do around the office?
Every department designed a hole that wanted to. Yeah.
He had this golf ball launcher, right? It was like all controlled, and so you put it into the hole, and then it, catapults your golf ball. I don't remember all the details of it, but it was really cool, right? And he did some other things too, just talking with him over the years, right? He has all kinds of ideas on things, and he's very, mechanical minded here. And I think there's a lot of outlets with mechanical engineering for that type of creativity. So
you guys could have a YouTube together and be Dave and Tim.
Well, there you go. Right.
I like it.
How do we incorporate that into Fishbeck? We need more subscribers.
Yeah, we'll have to work on that.
Click here and subscribe? Can you put a little?
Maybe. I don't know.
It's live.
Now you're putting them on the spot.
Yeah.
All right. So we've covered, okay, wow, that was a lot. We've covered a lot there. And I love how you you worked in the creativity, you worked in all the different versatility. Let's talk about some specifics now, some of the high-tech stuff, because you mentioned Blackhawk. It's not all that. There's sometimes it's air handlers, and I'm sure those are high-tech. They're high-tech to me, but I know we talked about electron microscopes.
Yeah.
Talk to me about that. Give me a little peek behind the curtain. What goes on?
Yeah.
And tell me who it's for, like some of those projects.
Sure. Well, yeah, and we do our share of high-tech stuff too, right? It looks different. Maybe in some ways it doesn't sound as cool, but it is. And you mentioned the electron microscopes. There's different kinds of those, but we've been able to do, we're I think on our 4th project now, and both of those clients of ours have said, hey, we have researchers coming in, and they need, I don't know, $2, $3, $4, $5 million microscopes. And that's a different thing we probably don't have time to get into, but just I've learned start to learn how they actually work. If you see these things with the covers off, they're so complicated. And you get into a little bit of that when you're designing even mechanical systems, because we have to understand to some level what's going on. But I've had great opportunity even to talk to researchers, and Kristen Parent at MSU, if you ever need to know anything about, let's say, a virus and how these things work, and the type of research they're trying to do to get their proteins to attach to the virus. And it's just fascinating stuff, right?
Yeah.
But we're designing the mechanical systems and electrical. We're doing all of it, mechanical, electrical, architecture. We're designing the rooms for these microscopes, and they have to have very tight temperature, humidity control. You get into the sound and vibration, electromagnetic interference, and you have to know all of this stuff. And those have been really cool projects, just working with those clients. I think we've been able to do a good job. They're just fantastic team and electrical. I mentioned David. He's been working on these projects mechanically, and others. And to be able to have people that have done it before and then take that experience. So, hey, they do the next one, and you did the first one, do the next one. And just to have these projects go pretty smoothly. And we were able to get firsthand feedback, even from researchers saying, hey, our readings, because the readings depend, the type of images that they get from the microscopes, it depends on the environment. Is it stable? Do they have low, are the acoustics really good, low sound, temperature, humidity, really tight control? And if they don't get great readings, usable, but maybe not great. And we've had fantastic feedback that, hey, you guys are doing a fantastic job. Like this, we want you to do the next one, because our readings, like we've had other people at other institutions look at this and they're like, this is really good, right?
That's good for us.
It is good for us, right? And that's exciting. I mean, and I like the connection on those where you do get to interface with the researchers, and that's fun. I think that's fun, right? And you get into you get into high tech stuff.
That's important. That's an important viewpoint too, because when you hear from the people using the equipment, it really helps you. Figure out what you need to maybe hone in on.
Yeah, and it's motivating too, right? It's motivating. It's sometimes you get on projects and there can be a little bit of a disconnect. It's like, what are we really doing here? Who are we really serving? And who's the end user? But it's really cool when you get the direct to the end user, and you can meet all their needs.
And I know that just from some of the projects I was working on proposals for years ago, that those aren't the only projects. Those aren't the first projects, obviously, that we did for those clients. So how did the existing relationships help us, or did they help us?
Yeah. Oh, for sure they did. And I think those are just a good testament to people even before my time and the service that we provide to our clients. And in mechanical, you think back to Doug Van Dyke.
Oh yeah.
And but
that's a deep cut.
Yeah. I mean, Paul Coops,
yeah,
doing commissioning out there, and John Yonkers, Jeff Shoemaker at Michigan State doing all the steam work.
I mean, that's structural. And you had something to say, but that's okay.
Yeah. Yeah. Maybe a little. Maybe they're okay a little bit, I guess. But yeah, I think long term, right? Just all the different touch points we've had with people historically, and then they're big shoes to fill for people like myself and the next generation coming up, because we've done so well at these places, and we have to continue that and do good work, and that's going to go a long way for these clients who need things done right.
That's a great example. Now, we said at the top that and you mentioned, when we were talking, that the best engineers are those that seek to understand why behind a project before they get to the how. Can you share an example of that, where that hit you, or where that realization came from?
Yeah, that's a good question. And I think it's something almost on a daily basis, right? As engineers, we try to understand why something is the way it is, so we can come to the right conclusion and not just jump to a conclusion or say, yeah, hey, here's the fix that normally works, just try this, right?
Yeah.
And I think as engineers, we want to try to understand why. We have that happen all the time, where someone will come to us and say, hey, we have such and such a problem, and we think we need to do this. I think that our job as engineers is to the extent possible, let's understand really what the problem is and what's that starting point, and not jump to a conclusion. It may be the same. It may be what you're saying, and you have all this other information that leads you to believe, yeah, we have a problem with our control system, whatever specifically it may be, right? But that may not be the problem at all. And I think that's the challenge for us as engineers, is to come up with the right solution. But we've got to do it as quickly as we can. I mean, I don't think you would say that, hey, engineers are known for being fast.
Methodical is what I would say.
Okay,
yeah.
methodical.
Yeah.
That sounds better, right? But we're sometimes, maybe we're perceived as, hey, we're a little bit, we take longer on things, right? Can we actually deliver something on time? So that's the challenge, right? That we have too, because we have to try to get all the inputs and understand the problem, process it, figure out, okay, here's the solution, and then give an output, right? Something that's reasonable and realistic and on time and all of these things.
So what kind of problems are you solving?
Yeah.
Like let's because there's always this project focus, electron microscopes. It doesn't have to be about that, but what kind of problems do you get called in to fix?
Yeah. Well, it's really all over the board. I'd say direct engineering. When we talk about direct engineering, it's more of our work that is, let's say, direct to an owner. Some with outside architects, we do some work there too. But where we're really working directly, let's say for an owner, and they come with a problem, it's really all over the map. One that comes to mind just recently, we through our environmental department, and this is fantastic, right? I think we're trying to increase the coordination between departments, and hey, do you have anybody that needs mechanical engineering? And we're trying to do the same thing. Maybe there's environmental services that our clients need. And so we had one local here, Hutchinson, and they have some paint booths, and they have some spray applications they do. And, they come to us and say, hey, we need to figure some things out on this. So we send out our engineer, taking a look at it, and we find out that, yeah, okay, here's some things that are off, and give them a report. This is some things you can fix. But in doing that, you find there's all these other problems with your ventilation system, and you have to pull a certain amount of exhaust, but meanwhile you're doing that, you have these other fans that are pressurizing, backfeeding, so you're actually blowing air out when you should be sucking it in. And I mean, but it's all over, right?
Yeah.
I mean, I get, mechanical engineering, HVAC problems, controls are such a big thing today, so I think that's something that for us is important to keep up on, is how to, understanding the controls so we can understand how to fix the problems.
Yeah.
And a lot of it is control based, right? And it's how are the systems actually being controlled. And there's been quite a bit of increase in the sophistication in controls over the years, maybe the last 10, 20, 30 years.
Have you ever worked on a project where you thought the problem was something initially, and once you kind of started digging into it, you found, it's something totally different. We have to pivot.
Oh, yeah. Yeah. Now you're going to ask me for an example.
I got to
think of an example.
If you got one.
It happens all the time. We might have to come back to that, actually.
Okay.
We might have to come back to that. But it happens all the time. I probably should have my example already for you, but
no, that's fine.
We'll get there. Maybe.
So when you're talking to, because you mentioned before, you've been doing this about 20 years, little give or take, and when you have a new engineer on staff or someone that's just starting out in their career, is there a tendency for them to just kind of get to the now or the how really quickly? And is this something you have to kind of teach them or mentor them in? Like, let's take it like the best analogy I can think of is, forgive me for this, and I don't want to open a can, but here we go. On the medical side, you've got MDs and DOs, and MDs typically are quicker to just kind of say, here's the problem, here's the pill to fix it. DOs are going to say, typically, well, why? Why do we have this problem? So do you find a lot of people coming out of engineering schools coming in with that MD mindset, and you need to kind of fix that, or no?
That's a great question. I think it varies.
Okay.
I think it does vary. It does vary. There's some engineers who you'd actually like them to ask the questions more and understand more, right? But then on the flip side, like I was saying, the problems with engineers that we have is there are times when we have to get to a solution
quickly,
right? Because nobody has infinite, like, come on guys, we can't wait forever for you to come up with this, right? We can't wait forever. You have to tell me what size is that air handling unit, because I have to design a building around it. So we have to know that, and so we struggle with that too. But yeah, I think the starting point does need to be ask the right questions to really understand what's going on. And I think with that, once you get to that point where you understand, the speed will come, because the speed will come. Now you've gone through all of this. You understand the why. You understand how things are working, how they're supposed to work or how they're not working. And so you can come more quickly to the right solution based off your experience. But I think you're right as far as, even let's say younger people, entry level, coming out of school, that is something that you want to see as an engineer. You've got to understand why something is the way it is, so that you can get to the right answer and have the right solution.
Okay.
And again, that takes time.
And it's
right?
learning how to ask the right questions too.
Yeah, right. And I do think that there's right questions to ask, right? Yep. It's, to really understand it, right? You just keep asking why and root cause analysis.
It's
right?
interesting that you're saying this, because we had an episode earlier last year with Steve Romkema and Ingi talking about their sort of design process architecturally. And it did center a lot on, we have to ask questions. Yeah. So I just find that maybe that's a whole design conversation, but it's interesting how those dots just connected in my
I think you're right, because they're trying to figure out, if someone tells you, hey, we want a building that's designed, we want this end result. Okay, so we have that happen mechanically too, right? I want this. Hold on, let me let me make sure, and let me make sure of what you're saying. Let me have a comfort level with that, because I don't know, you may be jumping to a conclusion on something, right? And our architects have to do that too, right? They have to understand why someone's saying so, because they know some things. They're pretty smart.
Yeah.
They know about how buildings should work and function, and they have to figure that out, just like we have to figure out the best solution mechanically.
Okay. So next week is Engineering Week. We alluded to that. Yeah. And the theme is Design for the Future. So can you, from your perspective, what is the future of mechanical engineering? I mean, that's a huge question, and you can't possibly answer it totally. But just snip it. What's on the horizon?
Other than managers of AI?
Yeah. Or is
maybe?
That... Okay.
That it's such a good question, and it's something actually since we first talked, I've been thinking about it. I think it's a difficult question to answer. I mean, at one level, engineering is engineering, and these principles that we've been talking about, I don't think that ever changes. But you think about, I go back in my mind. You look at some of the engineering feats, let's say, of the Industrial Revolution and in the past century or the past 200 years, and you look at some of the mechanical things that have been designed and produced, and it's incredible, right? It's incredible, but we're beyond that, right? Because you have tools and you have things in place that get you to that point. So now is your starting point farther along, and so how do you manage all of that? I'm probably not being real clear in the answer, but it's a difficult thing. I think engineering is engineering.
Yeah.
And the problem solving it's always going to be there, but it's probably more just increasingly going to be different types of problems that we're solving, right? I mean, it's like, as an engineer, I love a challenge. I think engineers love a challenge, right? Let's figure this out. It speaks to what I was talking about, figuring out why something is the way it is.
Right.
It's just probably less on the technical engineering side of things as you go, right? Because there's things in place, and it's like AIs, and systems that can do a lot of this for you.
Yeah,
you had to do it
technologies
before.
change. You have to adapt.
It changes.
You still have to solve the problem.
You still have to, and the new problem is maybe just figuring out how to use that. I mean, that in a sense, that's an engineering problem too, right? How to use that.
Whoa.
Hey, you can.
Everything's an engineering problem.
You can put everything in a spreadsheet. Did you know that?
That should be a wrap up point. That's perfect. That's a good.
Just put it in a spreadsheet.
Okay.
Yeah,
I feel okay. Look, we could keep going, and that's usually a sign that we're on to something. Okay, but we're running up against our timeline. So I have one more quick question. Answer it as quick as you can. So what kind of advice for someone who's curious about an engineering field career? What advice would you give them, or would you give your younger self, young Ted, to help you be successful in this field?
English, communication, public speaking.
That's
there you
good. Go. That's not what I was expecting. So that's good. I wish I had left more time to talk about that, because I think that's important. Communicating these ideas and concepts.
Yeah.
Being comfortable in front of people.
Yeah.
Explaining the why.
And as things go, your job just becomes less technical and all of that, right? So having those skills is important.
Yeah, for sure.
There was a time doing this right here, my voice would be shaking through the whole thing. I'm not kidding. There was a time
really?
I hated this kind of thing.
I can't see it. Well,
I did. I'm not totally comfortable either, but I did a little bit of Toastmasters, public speaking, and I didn't want to, but I did it, and yeah, it really helps. Like, if you can get comfortable there, I think it's important, right? It's important for our job. So
for sure.
Yeah.
Well, unfortunately, we have to be done, and we could keep going.
Yeah.
We're at the end of this one, but from we've talked about high tech engineering. We've talked about the power of asking why. I hope this episode gave you some good insights into the future of design and innovations. Ted, the TED Talk was great. Thank you for joining us. Appreciate you. And we'll see you guys next time on the next Fishbeck Learning Exchange.
Thanks, Chris.
You bet.